Hello, and welcome to the first episode of the Encryption Files. This is going to be the pilot where we go over the who, what, and why. So, who we are, what we're going to be covering, and why we think this is important to cover. So, let's go ahead and get right into it and start with the who. We're going to start with the company that we're representing here, which is Handshake LLC. It's a startup in Reno, Nevada. It was started by three college students, three college graduates actually. All three of us went back to college. We're all three currently in college, and we all do hold degrees in our respective fields. So our main focus at the moment is on encryption, information security, and secure communication. By that, we mean not just communication with inside of networks, but also on WAN connections, so external networks. Um, the encryption part of it, we will talk about decentralization. We will talk about how we plan on assisting with some of the current problems and overview of some of the current problems in the standards that people are using currently. We're looking at new ways to secure network traffic through encryption as well as hashing um, and other means of securing not only the data but the communication barrier there um, between transport layer, et cetera, et cetera. And we'll get into the layers and all that later on. So we're creating new ways to authenticate users over the internet. Some of the current standards have flaws that haven't been exploited yet. Not to say that they couldn't be exploited, but they haven't been yet. And one of the main focuses of Handshake LLC is to harden it when it's not necessarily necessary yet. So by that I mean being proactive instead of reactive. And it's important in today's day and age that we secure our information because banking information or transactional information between PayPal and et cetera, et cetera, et cetera, all these things that are online, even your text, emails, phone calls, everybody's buying things through things like Amazon and eBay and the online presence is becoming more and more inherent in the average consumer's household. So this information security of being able to use credit cards with the touch of a button or the scan of your phone across a pad or these things become very important when it comes to securing it, and that's a lot of what Handshake's looking at and how we can bring in modern technology as well as making changes to technology that already exists and making it work in new ways. So I am Gregory Owens. I'll be hosting the encryption files, and I have a long experience in hardware and software. My family is very technical based. My father is actually a systems architect for a large gaming industry and or a large gaming company, sorry, inside the industry. And I've been developing self-taught and as well as classroom taught and online classroom taught software as far as HTML, PHP, C Sharp, JavaScript, Java, Python, etc., etc. It's kind of my life since I've been very young. So lifelong dedication to technology and security. Security has been something that I've recently gotten into with Handshake in the last probably year and a half, 2 years, and really dedicating myself to researching it and understanding how current technology is securing our information. Like I was just talking about, I have knowledge in multiple programming languages, markup, scripting, and styling languages. Um, I've been, as I said recently, researching very much into the modern encryption and hashing methods that are being used currently and how the underlying technology works, not just, how to apply it, but what it's doing to quote unquote hash something or quote unquote encrypt something. Um, I have a lot of knowledge in the industry standards such as OAuth 2, which is a current industry standard for user authentication across APIs, as well as OpenID, which is another one. Um, I also have quite a bit of information in modern APIs, how to use them, how to secure them, how to write them. So that gives me a little bit of insight in there on how this stuff's being used in the background as well. So some of the stuff we're going to be talking about, like I said just a couple minutes ago, we're going to be talking about the current standards of encryption. We're going to be talking about current standards in user authentication, um, and communication between computers as well. How does the computer actually talk to the other computer, and what does that stream look like as it's being sent across the network, and how can modern ways or modern standards be sniffed out or captured and used against you. So the current encryption standards and their flaws, communication standards like I talked about from computer to computer and some of their flaws, authentication standards such as OAuth and OpenID and some of their flaws, and how Handshake LLC is getting involved as well, like I was talking about. We're going to be looking at decentralizing encryption and hashing. We're going to be looking at hardening site-to-site communication, whether that be to client, peer-to-peer, or server-to-server. Hardening authentication flows, so the actual flow of authentication from a server to a client or a client to a client. We're going to be looking at how to harden those communication barriers and make it more secure in the end. And then the world of tomorrow, we're going to be talking about current technology, what's available on the internet, how much of your information is actually on the internet, and why we should be worried about how secure our information is being put across the internet by large companies or data miners, and a lot of these different possible negative impacts, and how you can be not necessarily hacked, but how your information can be scooped without you even necessarily having any ability to secure it as the standard sits today. So everything today of tomorrow should be encrypted. As we move into this age of information and age of technology, it's important that our security follows with the technology. And by that I mean that our text messages and our emails and our phone calls from phone to phone, and there's no reason why that information couldn't be encrypted with the technology that exists today. So we're going to be looking at encryption information as a decentralized object, a lot like blockchains such as Bitcoin and Ethereum. Um, Modifications, obviously, because it's not going to be a public ledger. A lot of these decentralized encryption authorities will be privately held in some cases, or they could be publicly held in other cases. It really depends on the situation, and it depends on the need or the use for the client and uh, the host, whoever that is. So that moves us into companies that stay client-eccentric in their privacy policies will potentially provide untrackable and thus unhackable communication. And what we mean by that is if you have a big provider, let's call it a cell provider, for instance, that's offering um, client-eccentric privacy policies where they themselves are not capturing the data. They're allowing the data to be go through an encryption standard and be encrypted from spot to spot, whether that be phone to phone or phone to tower to phone. Through that process, all that information is encrypted based on data that's previously gotten through authentication flows and things like that. And if that's the case, then theoretically, um, the government or big data miners couldn't get your information if the company wasn't purposely capturing it. Because if they weren't purposely capturing it before it was going through the encryption standard, which if that was happening on the phone, then theoretically that information can't be quote unquote unencrypted unless it's at the destination that it's supposed to reach. So that's a lot of what we're going to be talking about there. Um, the reasons that we're doing this is the world of information. As information becomes more crucial, security needs to follow, as I was saying earlier. Nobody wants their information to be openly available. You, me, big business. Nobody wants their information, their credit card information, even their statistical data. Nobody wants their privacy to be breached at any point, and they want to feel secure. So a lot of what we're going to be doing is talking about how We can secure everything from, like it says here, a phone call or a text or an email. Um, and the average person lives in constant fear of security breaches. If you're not a technical person or you're not somebody that has a technical person in your life, then you may not know the next step of how to secure yourself or how to, protect against not just your computer and having an antivirus and going through the basics, but how to secure your credit cards and watching for the signs of how um, you can be easily tricked. Sort of like magicians are really good at, keeping your eye over here while they do something over here. Um, People that are good at information um, gathering and taking your information, they have similar tricks where they're able to distract you in a way and do something else that you may not even know is bad in some cases. So another thing that we go over is what you can prevent, how you can prevent data loss, some of the current uh, products that are being issued and things that may put you in risk. And then it's our intellectual property. Realistically, our data is our intellectual property. So you really want to protect it the way you would with any other asset, whether that be your car or your house. And everybody has an alarm on their car or their house, or a new camera that they put on it, or there's many different ways that people are securing their cars and their physical assets as well as their monetary assets. Um, but in a lot of cases, their intellectual property or their data is not being secured as well as it could be. Um, and we really need to stay knowledgeable and continue to implement against security breaches instead of reacting after the fact. That's something that has been a common thing in the industry, is to use a standard up until somebody breaks it. And realistically, you don't want to be putting out fires. You want to be building fire alarms to be able to check those fires or put them out immediately, or even building blockades, putting in preemptive strikes to um, harden yourself against possible security breaches, et cetera, et cetera. The point being is that you should constantly be hardening your security, whether it be locally at your desktop, whether it be in the cloud, whether it be on your corporate network. The point is that at some point you have to reevaluate your security, and it may be valid at that point, but the evaluation needs to happen. And in some cases, a certain amount of research needs to take place as well, so that you can validate not just from standards and from the way everybody else tells you to do it, but also yourself. And read some white papers, understand how this stuff really works, especially in the corporate world, because too many people implement things that are they're told to on the internet um, by trusted sources in some cases, and it may have been valid in older circumstances, but the internet doesn't parse itself. So a lot of this older data is still out there and being used when there's newer ways to do it, etc., etc. So that's a lot of what we're going to be going over in this series called the encryption files. This is all brought to us by Handshake LLC. We're providing this information to you guys. Hopefully it helps. Hopefully we're able to inform you about some of the current security breaches and security data loss, as well as how to harden yourself from it. Um, and hopefully we can give you some insight into what Handshake's doing and how we're helping with the overall encryption of what we like to now call the Internet of Things. So I appreciate you guys' time. Hopefully this was insightful into what we're trying to cover here, and hopefully you're interested. We'll see you next time, and have a great day.